Hey guys, so today you and I are going to talk about academics. So let's get into it. So the question in question was, Frederick, I have a question that I hope you can cover in a future video. What are some differences between academia and industry that computer science students should know about? Like, are there any topics or technologies that are used in work settings that aren't covered in the CS curriculum? Oh God, that's a lot. I'm not going to be able to go through that with you. One thing I've noticed is that functional programming languages are more popular in academia, even though there aren't many jobs for them. I think people in academia take pride in being unique, using more obscure programming languages and whatnot, because they see big stuff like Java and C Sharp as being too mainstream and boring. I don't agree with that kind of attitude, though, but aside from that, I don't know much about software development jobs with how much different they will be than what I've learned in the university courses. Yes, there is a big difference between academics and the industry. That is why nigh on every single software developer who comes out of the academic world is, for most intents and purposes, useless until they can get a mentorship or something like that. You study mostly theory when you're in the university, and that's not a bad thing because you need to start somewhere, and theory is as good a place to start as any place. The thing that usually is lacking though is, as you identified, the tools of the trade, or the like there's a focus on the theoretical things that is going on in computer science. So an example would be, yes, functional programming languages is popular in the academic world. And it really is the same phenomenon that I see continuously in everybody. Like, this is something that you should just accept. It's a part of the industry. It is a very positive thing, but it can also be a very damaging thing. And this is, I promise you, you're going to go through this. I guarantee you're going to see this before the end of your career. Either you are going to be that person, or you're going to meet someone who is like that. There are so many things going on in software development, and there's such a massive community of innovative people, smart people, passionate people who love this area of technology so much that they continuously push for newer and better things. Now the problem with that is that you sometimes forget that industry doesn't care about that usually. Industry cares about results and what's mainstream and what's stable and what's going to get the job done. And whatever is forward thinking or different or a little bit unique or has some quirks, that or a lot of bells and whistles, as I like to call it, is the thing that most people will get excited about. And that's why you see most of the tech talks being about these sorts of things. It's actually funny because you don't realize that quite a lot of the tech talks about certain concepts or new ways of working, or say functional programming and so forth. There, do you think about it? Why do you think they are there? Well, they're there because nobody's using it, or that they're trying to get you to use it. Because the thing that is boring and everyday, well, that's not fun to talk about. Nobody's going to come to a tech talk. At least no senior, respectable senior is going to come to a tech talk on and get to learn the, I don't know, the values of the Java programming language. What? That's not what. Why? We're already using it, right? It's the same phenomenon. The thing that I think is lacking, I mean, you're going to have to accept that all the people who get really nerdy and want to nerd out about, say, functional programming, it doesn't have to be functional programming, it can be anything. They will do that, and you're going to have that for the rest of your career. You're going to meet so many junior developers or mid-level developers who they will come back from a weekend where they read about something like microservices or service meshes or cryptocurrency or whatever. They are going to get inspired and they're going to say, let's rewrite the whole system, or let's work more in this way, or let's work more with the constant variables or whatever. Like, they will have something, and that's going to continue for the rest of your career. And the only real downside with it, I would say, is when they allow their emotions to steer their brain. and that is what you have identified here, because the reality is that Java and C# are vastly more popular in the industry than any functional programming language on the planet. I would even say there is no functional programming language that gets even close to being as mainstream as C# and Java. That, but that doesn't mean that these are bad languages. It's just that that is the mainstream thing. The thing that I think, if I were to change anything with the academics, because I think that you still have to understand that you can't just say that academics are bad or something like that, because it's not the case. It's simply that there is a bit of a misalignment, I would say, between the industry and what the industry values and what the academics are teaching. But I think that misalignment should be there, because what would be really dangerous would have been if the academics would academics would go and say, hey, you know what, we're not about pushing things anymore, we're not about trying to focus on theory, or we are about trying to get people to learn exactly the thing they need to learn in order to do things in industry. And that is also a dangerous route, because then you're actually taking away from something that shouldn't be about money and productivity and so forth. It should be about the advancement of our understanding of something. Like, it's an example would be it is extremely dangerous to let a private corporation fund and set the roadmap for scientific studies in some cases, because they have other agendas than, we just want to learn how the universe works. It's the same sort of problem. That is a very different topic, but I hope that you understand what I'm saying. The thing that I think we should address, though, is that there's a lot of focus on, and that's what you're going to notice probably. You're going to learn a lot about the theory of specific types of algorithms and classifying algorithms and big O notations, time complexities, basic complexities, etc., etc. There's going to be a lot of heavy emphasis on that. But in the real world, you're much better off learning about the tools of the trade. And when I talk about the tools of the trade, I'm talking about everything like databases, version control systems such as Git, web frameworks, etc., etc. There's so many tools, right? These are things that you need to learn, because that's the stuff that we use every single day when we're working with software development. The other thing that also goes missing is a good understanding of code structure and proper architecture. Most of the legacy systems are bad, not because the developer who wrote the code wasn't aware of that there was an O notation optimization that he could have done here. It's actually often more related to the fact that they've made poor design choices. And designing maintainable, well-structured software is a lot important to the vast majority of companies than whether or not you can identify if this is a exponential or a linear problem. Because in many cases, yeah, sure, maybe you could identify it and you could put some time into it. If it's a really important function that crunches a lot of data, that performance optimization is going to help you. It's going to make a big difference for the company. But in many cases, the business logic is structured in the way that it is, and you simply don't, even if you can see that this could work faster, even your big own analysis will not actually change anything, because you can't optimize it. You should know about it. So I'm not saying that you shouldn't learn about Big O. It's a really good tool to have in your toolbox. But the emphasis, I think, is a little bit worth, because most of the time the problem is not that you wrote a function that uses a poorly performant implementation of something. Most of the time the problem is that the code is so messy that nobody really knows what's going on. So what I want you to take away from this is that there is so many things that are different between the academic world and an industry that I cannot possibly go through like all of them and everything that you should know. What I urge you, if you're a young upstart, fresh starting software developer, is to learn the tools of the trade. You need to understand, go and have a look at the job postings, go and talk to developers that you know and ask them what tools are you using, and they should be saying things like databases, Git, an IDE, web servers, etc., etc., Docker, whatever, right? You should get a range of tools that you should be able to understand, take a look at. And then the main thing that I would change in the academic world, I don't think that we should not try to make academics into business oriented things, because I think that that would be a very big mistake. But I do think that we could change the focus time, or the ratios of focus, a little bit, from being so very emphasizing on big O notations and execution speeds and so forth, to being more focused on good code structure. Because good code structure and semantics about well maintainable code is the main problem for most code bases in IT. Most of the problems that you will face will be directly correlated to legacy issues that are caused by the fact that people don't really know how to model their domain problems in a good way, and so the code kind of becomes hacky or falls to pieces very quickly, and that problem just cascades onwards. Have a great day.